So anybody who was asleep, who hasn't been outside since the conference started? Whew. Yeah, it's rough. Who uses Dropbox? Who uses Netflix? Who's looked at the cool pictures from Mars? Who uses Pinterest? Not nearly as many. That's good, that's good. I'm proud some of you admitted it. Some nice Art Deco cupcake decorations the other day. They're going to be fabulous. Anyway, all of those things have something in common. They all use S3 a lot. I really like the pictures from Mars story in S3, right? There's a little robot on Mars who sends a picture into a satellite in geosynchronous orbit above the Earth. That satellite makes a TCP connection to s3.amazonaws.com and puts the image. I mean, pictures from Mars. S3 is a tremendous product that does tremendous things. It holds trillions and trillions of unique customer objects. We're not counting EBS snapshots in this. We're not counting all the ways Amazon and AWS use S3. It holds trillions of your objects. It's tremendous. It's incredibly durable. It's designed to survive the simultaneous failure of multiple physical facilities, right? So your data center on premise, it's one building. Truck runs into the building, you have a problem. A truck runs into a building that holds S3, you won't even know. You won't even know, and that's the idea. We're delivering that durability to you as a service. It is, in aggregate, incredibly fast. 1.5 million puts and gets per second to the S3 infrastructure. S3 is very, very fast. So I want everybody in this room to use S3 well, because it is possible to do a poor job using S3. And S3 will protect you from yourself. S3 will continue to operate well, no matter how you use it. But if you use it well and you help us help you, we can make S3 a lot better together. So we're going to get into a bunch of details. We're going to talk about a bunch of topics. We're going to move through this very, very quickly. We have a lot of stuff to cover. A videotape of this session, the code behind the demos I'm going to show you, and more sample code, plus some other stuff, is going to get emailed to you on Wednesday. So you're going to have access to all of this, and the code, and the executables on Wednesday. So if you're not keeping up, that's perfectly fine. We can get there. We start, before you even begin, if at all possible, by choosing a region. Okay? We have 9 regions spread all around the world. Each region is made up of one or more availability zones. Every availability zone is made up of one or more buildings. Sorry, each region has at least 2 availability zones. Each availability zone is made up of one or more buildings that are separated by some number of miles, so we're very redundant. When you pick a region, you've got to consider some things. If you're building an application for the financial services industry, and all of your customers are in New Jersey and New York, then you'll probably want to be in the US East region, because speed of light means that's going to be a little bit faster for them. If you're building an application for people in the EU, we have a region, EU West 1 in Dublin, you're going to want to put your data in there. Okay? If you're going to run EMR clusters, or maybe Kinesis, the new streaming service, against stuff in a bucket, or put stuff from Kinesis into a bucket, you're going to want to make sure your bucket is in the same region as Kinesis for performance. Legal and regulatory requirements, we talked about that. If you're providing services to somebody in Brazil and they say, I want my data in Brazil, you're going to use our Sao Paulo region or Sydney region, so on and so forth. And costs vary by region, right? Very transparent about our costs. They're all online. So just go ahead and check the costs and use that when you're making a decision. Okay? So we're going to start right off with a quick demo. Okay? And we're going to talk about the details of this demo later, but I want to get everybody looking at what some simple changes can do. We're putting a 100 megabyte object from from a machine in US East 1 to S3. We're uploading it sequentially. So we're taking the first bit of the file, we're putting it, we're taking the second bit of the file, we're putting it, we're doing it as a single thread sequentially. Okay? If you're using if you've used C and you're against our native RESTful interface, this is how you're doing it. And it's not terribly fast. That 100 megabyte file took 11.9 seconds, 12 seconds to upload. Okay? If you do multi-part upload, right, all of a sudden that turns into 5 seconds. And the way that everybody in here can start doing multi-part upload is use one of our SDKs. All of our SDKs, all of them, implement multi-part upload automatically and transparently to you. And what multi-part upload does is look at the size of the object, decide how many chunks to chunk it into, right? Most of the SDKs do that based on the number of cores you have in your system. Right? Chunks it up into that, puts it into S3, and then you can get it as a single chunk later. So it's called multi-part upload. It's been around for a very long time. A lot of people don't use it, and I don't know why. Incredibly easy to use. Just use our SDKs, and you'll get good multi-part upload performance. Okay? You can implement it yourself as well, but you'll get good multi-part upload performance. We do the questions at the end of the...
I just want to make a quick comment. It's also the new CLI.
I should mention that as well. The new CLI is based on the Bodo SDK, so the new CLI has multi-part uploads. So if you're just doing bash scripting, it's already there for you. Where'd my clicker go? All right, so let's talk about naming, all right? I want everybody's going to get access to all of this stuff on Wednesday. For those of you that have your phone out, have your iPad out, or of course have your Kindle Fire out, I want you to go to that URL. Right, that URL is going to lead you to the most important piece of documentation you need to have if you're worried about maximum performance on your S3 bucket. Okay, so everybody go there. The naming scheme of your keys is important. We use your naming scheme to spread your workload across lots of our resources. So if you have a poor naming scheme, we're not going to be able to spread your data across our resources. And so you're going to have a ceiling on the performance of your bucket of about 100 transactions per second. We're going to talk about transactions per second. That's going to lead you to the document that discusses naming schemes. And we're going to go into some of the details about naming schemes now. But this is important. I want everybody to have that in their bookmarks. Let's look at what a transaction is. A transaction is a put or a get, for the most part. Let's look at a theoretical mobile application. I have a mobile device. I have a bucket. I have some EC2 instances that I'm going to do work on that bucket with. I start by, say, uploading a video to S3 off of a mobile device. That's one transaction. That's a put. My cluster of EC2 instances gets that video out of the bucket. That's 2 transactions. It transcodes them into 3 other formats. That's what my application is doing, and puts them back to the bucket. That's transactions 3, 4, and 5. And then the mobile client gets those. That's transactions 6, 7, and 8. So one event in my application is 8 transactions. If you've ignored my advice on naming schemes, your bucket is going to be able to sustain 12.5 of these events a second. Right? You're going to get 100 transactions per second out of a bucket. Each one of your events is 8 transactions. You're going to get 12.5 events per second. If you have 10,000 users, each user does 10 of these events an hour, a bucket without a good naming scheme isn't going to hold up. You're not going to get the performance you want. You're going to get 503 rate limit exceeded errors. You need 224 transactions per second. So this application will need to pay attention to its bucket naming scheme. Here's the anti-pattern. Here's what's not to do. We store things in S3 lexicographically. Great word for alphabetical order. Isn't that good? If you store everything with the prefix of your key name is the same, there's no arbitrary values there, there's no randomness there, we can't spread your data set across lots and lots of resources. We can't intelligently distribute the load, which means you're stuck on a limited amount of equipment, which means you're going to have a maximum performance of about 100 transactions per second, and your performance is going to be inconsistent. One day it's going to be fine, the next day it's going to be a little bit slower, the next day it's going to be fine again, it's going to be inconsistent. So, we're storing things here, real easy example, year, month, day, minute, hour, second, milliseconds. What's the easiest way for me to improve the performance of this bucket immediately? Just switch it. I just switch it. If I put milliseconds and seconds first in the prefix of my name, I have arbitrary values there. Now our service can spread your workload across lots and lots of equipment. That's all it takes. I had a customer that came to me and said, Craig, my bucket is really, really slow. And it's inconsistent. And it's not scaling the way I expect S3 to scale. And I said, well, let's look at your naming scheme. And we look at it, and all the objects are prepended with 12 zeros. And I say, why in God's name are all the objects prepended with 12 zeros? And they said, well, we wanted all of our object names to be the same. So when we were storing them in a database, we know how much space they were going to take, so we're padding them. And I said, no, you're doing it wrong. We swapped everything around, so they still had their 12 zeros. They just put them at the end of the string and not the beginning of the string. And a month later, they were happy as could be. So it's an easy change for most people to make. Other ways to do that, one of my favorites, is you can store objects as a hash of their name. So my dead mouse mix MP3 file, if I stored a whole bunch of these as dead mouse mix, it wouldn't work. If I calculate the SHA-1 of that file, or the SHA-1 of just the name before I put it, and then I put it with that as its name, and I put the original name in the metadata, the performance of that bucket is going to be dramatically increased. This can also be a way to implement deduplication. Right? So if you know that you're only going to have original object names and you want to deduplicate based on object name, by creating a hash of the object name, you'll be able to deduplicate fairly easily. You can prepend your key name. You can leave your key name dead mouse mix, and you can prepend it with a short hash. So maybe do an MD5 hash of the name, take the first 4 or 5 characters. That's going to add some arbitrariness to the beginning of your key space. Okay? You can take epoch time, reverse it, because I need milliseconds first, and prepend your object with that. So the goal here is to have your key begin with some arbitrary or random values. So I can use that random value to distribute the workload. That's very important. You all need to do it unless. Okay? It's an anti-pattern when we start talking about lifecycle policies. If you want to tier things out to Glacier, or you want to automatically delete things, the way that you can filter that is by the prefix of your key. So this isn't going to work really well if you want to do lists with prefix filters. If you absolutely need to know without running a list or without doing any calculations what an object is called in S3, you have a local index that you can't change or modify. All of these things mean that you're going to have a hard time changing the name. Okay? Here's an example of how to manage thumbnails. Right? You can store craig.jpg as, because that's the original, I'm going to prepend it with original and then a hash. And then if I create a thumbnail image, I prefix it with the word thumb and the same hash. So I can now associate my original image with my thumbnails fairly easily, but I still have some arbitrary characters in the name. Okay? So how do we solve for that? If I want to do lifecycle policies, right? I add some additional prefixes to help sort the names. We add images, we add movies, we add thumbnails small, medium, and large. So if you need to do lists, if you need to have the ability to list all of your small thumbnails, or the ability to list all of your movies, you can prefix like this. Okay? So this is incredibly important. We've talked about this. Okay? Once you go, if I've inspired you, and you're going to go make these changes today to your naming scheme, it's going to take a little while to propagate. All right? If you need it to propagate immediately, you can open up a support case, and you can say, I've changed the naming scheme for my key space. Can you have that impact my ceiling, my performance ceiling immediately? And support will help you with that. Okay? Let's talk briefly about CloudFront. CloudFront's a fairly compelling content distribution network. So we're going to run a quick demo. I hope we're going to run a quick demo. I hate live demos with a passion. Let's try this again. There we go. All right, so let's run a quick CloudFront demo, and I'm going to talk about what CloudFront is. CloudFront is a content distribution network. It has 46 physical locations around the world with some equipment in them. And you can use these locations to cache your S3 bucket. So if you have users spread all around the world who are coming back to an S3 bucket to get and to put data, they're having to traverse a very long network to get there. And that's very latent, and they're having a poor customer experience. If we put CloudFront in front of the S3 bucket, all of a sudden their experience improves dramatically. So what we're doing here is we are getting from a Sydney S3 bucket a whole bunch of files. We're getting them a bunch of times so the demo is statistically relevant. Again, everybody's going to get access to the code that runs this, and so you'll be able to do this yourself. Now we're getting the exact same data from CloudFront. Exact same data from a cached POP. So on average, it took us 3 seconds to get these files from S3. It took us 0.1 second to get the exact same content from CloudFront. One of the really exciting things about CloudFront is it dramatically lowers the number of gets from S3 because people are getting things from CloudFront. What that means is that in many use cases, putting CloudFront in front of your S3 bucket lowers your total cost. I can take your downloads from 3 seconds to 0.1 seconds, and I can lower your cost to the solution at the same time. So if you're doing gets, you need to look at CloudFront very, very strongly. If you have a method or a function that does gets in your application, all you need to do is change the DNS name for that get, for that function to your CloudFront DNS name. And I'm going to show you how to set up a CloudFront distribution because it's pretty easy. You're low latency because your customers are right next to your POPs, because there's POPs everywhere. There's 46 POPs. We've added some new ones in India and Asia Pac very recently. There's a very high transfer rate. So we have 46 POPs spread all over the globe, and every one of those POPs has a whole bunch of bandwidth. And now your application has access to 100% of that bandwidth. So you have a high transfer rate. We've been talking today about web distribution, that's static content distributed via CloudFront. They can also do streaming video, which a lot of customers use. So I want to show you real quickly how to set up a CloudFront distribution, because it is beyond easy, and I want everybody to go do it. So you come here, you find CloudFront. You create a distribution. We're going to do a web distribution because we're distributing static content. We're going to continue. Your origin domain name. Now, of course, CloudFront can distribute content from any website hosted anywhere. It doesn't have to be an S3 bucket. But S3 bucket's kind of the way we do it normally. So we drop down. That's the original name. That's the source name. You can pick all kinds of options, HTTP or HTTPS. You can do a custom certificate. You can set TTLs. You do some stuff with cookies. We're going to skip all of this. And we're going to hit create. There it is. Done and done. So that's my new DNS name. It'll take about 10 minutes for that to propagate through Route 53 and be available globally, and you can start doing gets from your S3 bucket at that DNS name. The first time you get an object, it's going to take about the same amount of time it would have taken with S3. After that, it's going to be tremendously faster. That's how long it takes. What did that take, 30 seconds? Something about that? All right, so that's CloudFront. Let's talk now about big black screen. There we go. Yep. That's better. So let's talk now about multi-part uploads. All right? Multi-part uploads are a much more efficient, much more effective way to put data into your buckets. They allow faster, more flexible uploads. So you have a 1 megabyte object you want to put to S3. You can open up a stream, and you can put that object sequentially, just like we talked about getting an object sequentially earlier. You can, that'll work. And if you have a wired connection and you're on a desktop, chances are you're not going to get any resets. Chances are you're not going to run into any issues. But if you're on a mobile device, if you're on an even slightly flaky network, your chances of getting a network reset during that 100 megabyte put, fairly high. So what we do is we chunk that object into multiple parts. And we put each part up as a completely independent transaction. So we take that 100 megabyte object and we put it up in 4 25 megabyte chunks. So now, the first one uploads without a problem, the second one uploads without a problem, the third one gets a connection reset. I only have to upload that 25 megabyte section again. So it's much faster, much more reliable. I can also put these in parallel. So if I have 4 cores on my machine, the transfer manager in our SDK is automatically going to upload each one of those 25 megabit sections in parallel. So multi-part upload is very powerful. Let's do a quick demo. This is the same demo we ran before. I want to point it out one more time. We're uploading a file 1 bit at a time. It's going to take a very long time. Stand here and introduce a little bit of pain. Who here does multi-part upload already? Who here does single-part upload or isn't sure? How many people are going to switch to multi-part upload? There we go. Give yourself a hand. Come on. Live demos, they're very dangerous. All right, so if you're going to start doing multi-part uploads, the important part is choosing the right part size. So that's very important. If you pick too many parts, you're going to spend more time putting or setting up and tearing down network connections than you're going to spend sending data. So you don't want to pick a very small part size. If you pick a really big part size, it's not going to get you the advantages you need. So this is usually something you want to test in your own application. Quick sort of baseline is as many parts as you have cores on the device. That works really well for desktop and server clients. It doesn't work so much for mobile. On mobile clients, you have to decide if you want to saturate your network connection, because the more parts, the more likely you are to saturate your network connection. On high bandwidth networks, we say 25 to 50 megabyte chunks. And on mobile networks, we say 10 megabyte chunks. That's our general guidance, and that's a good place to start. You can parallelize your gets as well. And this is something that people miss a lot. So the same as we can upload chunks of a file, you can get chunks of a file. You can say, give me chunk 0, or give me part 0 through 1024, 1025 through 2048. Okay? This compensates for unreliable networks, as the same as pudding does. It benefits It takes really good advantage of all of your cores and all of your processors and all of your bandwidth. It's a really good way to saturate your network bandwidth. A trick that we haven't talked about a lot is if you're doing multi-part uploads and you're putting them in sizes of, say, 10 megabytes, get in 10 megabyte chunks as well. If your gets are aligned with your puts, your gets will be tremendously fast. So pick a standard size that you're going to put objects with using the multi-part API, and with all of our APIs you can specify, I want this object size, or this individual chunk size, don't calculate it for me. You're going to fix it. If you then get using the same chunk size, incredibly fast gets. Incredibly fast gets. Okay? So let's look at a demo of parallel range gets. Okay? So we're going to, you didn't see that. The boss man had his head down. He doesn't know what people are laughing at. He's very nervous. All right, so we're going to start getting an object with a single request. That's doing a get on a JPEG file. We're just bringing it down locally. It took us 7.5 seconds to get that file, 7.4 seconds to get that file. We do it in parallel. It's a 100 megabyte file. We chunked it up into 4 25 megabyte pieces. We got them in parallel, and as expected, we got them in 2.5 seconds. It's easy. It's easy. All I said was, give me the first 25% of the file. I made an API request to S3, give me the first 25%. Then I said, give me the second 25%, the third, and the fourth. I got them all at the same time, and then I had to put the parts back together again. Java, Python, and Ruby SDKs have a function to put the parts back together again, but if you want to do it in Bash, it's just cat. Just cat the pieces back together. There's nothing complicated here. This isn't rocket science. It's not fancy. It's just very, very fast. Thank God Almighty, that's the last demo. All right, so let's talk about SSL. If you've done what I've said, and you've said, I'm going to do multi-part puts and multi-part gets, and you're using SSL, which I hope you all are. Who does everything on S3 via SSL? Who does it via non-SSL? Okay, all right. Mostly SSL, that's good. If you're following my advice and you're doing lots of threads and lots of parallelism, you're going to become CPU bound. That's a great thing to be. Pushing your bottleneck from your network and from S3 to your CPUs is a great thing. That's a good problem to have. How do you solve that problem? You enable AES-NI support in our SDKs. We have documentation online on how to do that. Right? There's a link in the presentation. You guys are going to get a copy of it on Wednesday that shows you how to patch the Java SDK to enable AES-NI. Many of the instance types in the EC2 fleet have access to AES-NI. Most new processors out in the market and lots of mobile devices have access to AES-NI. That's pushing the SSL work down into a processor, down into a special part of your processor. So you'll want to look at doing that when you follow my sage advice, and all of a sudden you're CPU bound because you're using SSL. Lists. Lists in S3 are hard. Who has buckets of over 10 million objects? Who here tries to do lists on those? Who here is tremendously successful with lists on those? Hey, we got a winner. Lists are really hard. So if you do a list on a large bucket, we return 1,000 results back to you, and then a token. You pass us the token, we give you the next 1,000. And we do it again and again and again and again and again until you get 10 million results. So lists are hard. But there are still some cases where you need lists. You have to do lists. We think you should avoid them as part of the regular process of managing your bucket. It can be sort of an audit thing you do once or twice a day. But it's not something you want to do all the time. But let's say that you need to get a list of let's say you're prepending your objects with the name of the customer that put them. And you need to get a list of all of those objects. You want to get a list of all of your videos or all of your 720p encoded videos. You want to get logs from a certain day. You want to view an inventory. There are reasons that you need lists. So how do we make lists faster? You want to parallelize a list. And we have some code samples that help you do this, but it's fairly easy. If you know that your data, if every key starts with A through Z and 0 through 9, you get a list for everything that starts with an A, and at the same time, everything that starts with a B, and at the same time, everything that starts with a C. Really easy to implement that sort of multi-threading in Python, Ruby, Java, anywhere you want. So now you've got 36 lists happening simultaneously. And now your list is all of a sudden 36 times faster than it was before. You've implemented some client-side logic, and you've made your list massively, massively faster. Okay? And we'll throw some sample code in the deck to show you how to do that. Build a secondary index. So whenever you put an object to S3, make an insert to DynamoDB. Whenever you delete an object from S3, pull a delete from DynamoDB. We just released a new JavaScript API and a set of cores support for DynamoDB. So in your web application, a user can put something to S3, and a user can do an insert to DynamoDB, and you don't need any server infrastructure to make that work. We released that a couple of weeks ago. Anybody using that new JavaScript library yet? We've got a couple. That's good stuff. And that makes it much easier and much more effective to build and maintain lists in DynamoDB. So, like I said, you're maintaining a parallel list in DynamoDB. With DynamoDB, you've got lots of different indexes. We now have global secondary indexes, local secondary indexes. The number of table scans is way, way down. So if you do this in DynamoDB and you say, give me a list of all of my objects which belong to user Jessica and are encoded in 720p, that's really, really hard in S3. It's really, really easy in DynamoDB. So you do that in Dynamo, it returns a list of objects, and then you can get those objects. So it's using DynamoDB and S3 together. So we talked about a lot. I'm going to leave plenty of time for Q&A, and I'm going to try and get you out of here a little bit early. Who's getting on a plane right after this? Yeah, all right, so let's get you out of here pretty early. We talked about picking a region. The most important thing, which is the naming scheme. I cannot stress enough how important the naming scheme is. All right? Don't use lists, if at all possible, as a regular part of your application. If you need to, let's push them to DynamoDB. Anybody here who isn't doing parallel puts and parallel gets, you're going to get a bunch of code that explains how to do it and makes it incredibly easy to do. Take advantage of it. All right? The multi-part put is built into every one of our SDKs, and byte range get is so easy it doesn't need to be built into the SDKs. It's very, very easy to do. All right? So, questions, please.